Hi class, I'm back again to talk about one last important concept for Chapter 2. So in Chapter 2 we've been talking about heat energy and the shortwave radiation that comes in, that hits the Earth from the Sun, and how a lot of that, some of that, about 30%, is reflected, and a lot of it transmitted through the atmosphere, and about half of it is absorbed by the Earth's surface. And then the Earth re-emits long wave radiation, which is a little lower energy radiation, and that long wave radiation that's emitted by the Earth heads up towards the atmosphere, and some of it is re-reflected back towards the Earth's surface by the atmosphere. What I wanted to talk about now is why is it that some of these gases are able to re-emit that radiation back to the Earth's surface? Because we hear a lot about greenhouse gases and about carbon dioxide. So the greenhouse gases, the really effective greenhouse gases, are gases like methane and water vapor, carbon dioxide, nitrous oxides. And one of the really effective greenhouse gases is carbon dioxide. And one of the reasons that it is so effective as a greenhouse gas is the wavelength of energy that gets it excited. And so in order to demonstrate the importance of carbon dioxide, I think it's important to understand why it is that this molecule gets more excited than other molecules. And it has to do with the molecular structure of carbon dioxide. So carbon dioxide, that molecule has one CO2, right? So one carbon atom and two oxygen atoms. So I'm going to pretend to be a carbon dioxide molecule. And so my head is a carbon atom, the one carbon atom, and then my fists here are the two oxygen atoms. And carbon dioxide happens to be a linear molecule. That means it's not bent like this. So you can imagine between my fists and my head are double bonds, double covalent bonds, with sharing of electrons between the carbon atom here and the oxygen atom. And what happens is that the energy that is emitted by the Earth is at the perfect wavelength to get this molecule excited. And when molecules get excited, they start vibrating, they start moving. And some vibrations are better at reflecting energy back, scattering energy. And some vibrations are not. And this vibration happens to be one that doesn't. It's symmetric. It doesn't reflect as much energy. It actually takes a lot more energy to get this going because it's stretching the bonds. And so it's different wavelengths that get this one going. But this vibration and this vibration are the vibrations that get carbon dioxide excited by longer wave radiation in the wavelength that is emitted by the Earth's surface. And also that vibration, because this molecule is doing this or it's doing this, it re-emits that radiation. Some get scattered to space, but a lot of it back radiates back to the Earth. And remember that back radiation is what we call the greenhouse effect. And the reason we have what we call global warming is that we've increased the amount of carbon dioxide in the atmosphere. We've increased the number of molecules that are up there doing this when they get hit by that radiation emitted by the Earth. And so if we have more of that backscatter, back radiation coming back down to the Earth's surface, what happens? If we put more energy in, more heat energy, we trap more heat energy, what happens to temperature? Temperature goes up. And that's what we call global warming. The greenhouse effect is just the phenomena of trapping the energy. Global warming is trapping more energy because there's more carbon dioxide and other greenhouse gases in the atmosphere.